Duncan said he wanted it recorded. Does it say it's recording somewhere? Yes, it
Yes,
does. I
yeah.
see it. Okay, cool. Then we went over the basic SAE rules, some of the rules for the tubing size, the positioning, connections, stuff like that. Today we're gonna, towards the end, we're gonna fine comb it, which that's why I want to do it twice. I'm okay with doing this lesson twice because I want everybody to read every line of it. Maybe not completely like study what does this word mean every single line, but I want to make sure that we get eyes on every line so we see if we catch anything that allows us to make exceptions next time or fixes we need to do. Does that make sense?
Hmm.
Actually, do you have that, the SAE document, the rules?
I think they were sent in the first email or
Okay.
like the second email or something,
If you
like the
don't,
rule book.
yeah, if you don't have it, I can
Yeah.
attach it right now, but you
Okay.
just tell me. Actually, I'm just gonna attach it anyway for everybody. If you can go ahead and just open that, have that open on the side of your computer in the background for now.
Are you sending it through GroupMe or in the
Yeah, I
chat?
just sent it through GroupMe.
Oh, okay.
Sorry. I'll try to send everything through GroupMe,
Okay.
unless we're having like some secret sauce discussion that the school doesn't need to know about. But yeah, I like putting it in GroupMe because the documents are all there, and I think you can call them all up separately without scrolling through. It's in like media or something.
Okay.
Just have that open in the background. So I'm going to elaborate on the present because I made a PowerPoint for Tuesday. Steven shortened it a bit because I was like, oh, okay. Because we need to work as officers, we need to work on getting a common PowerPoint together rather than having Steven do it kind of last minute, which is our fault. But I think it's easier if we all use like Google Slides in the future, which I think we're going to try to do this next time. So nobody needs to worry about like formatting issues because he uses an Apple. Some of us use Google Slides. Some of us use PowerPoint. You know,
Hmm.
I use PowerPoint because it helps me be pretty on this little design. So we're gonna make a jig for the chassis, or for every chassis if we make it adjustable enough. Do you know what a jig is?
No.
Okay, so this picture I think is a good consolidation or representation of English, right? Basically, it's a bunch of like, you can think of it as a bunch of helping hands that are helping you to precisely position something or place it either by itself when you're working on it or relative to other pieces as you assemble them, uh, which is helpful, especially if you want to mass produce something, right? Or if you want to experiment with it. I think it will help us experiment with designs without putting anything in stone by welding it in place, and then it's a pain in the butt to undo it sometimes. So here, if you look at the bottom right here, these lateral beams are forwards and backwards adjustable, right? So we have adjustability in what you would call, if you're looking on a sheet of paper straight down, the long y-axis. These right here are adjustable on the x-axis side to side, and then you have some little attachment mechanisms here that are adjustable on the z-axis. So we can use the y-axis sliders and the x-axis mounting. We'll need to come up with some mounting for here, obviously, because it looks like for this mount for them, they just kind of cut out the tube to be notched to match another tube that slides into place, you know?
Hmm.
I think, I'm not sure if we're going to do it that way. I need to figure out what kind of attachment we want to use to get from this sliding piece to the actual chassis bar or tube. You can call it either right now. I'm thinking about having detachable, like, if you can imagine a hand that detaches like at the wrist, so the wrist is the attachment point to the little vertical beam, and then this will grip the tube, right? It's a 1-inch tube, so they're all going to be the same. And then we'll have adjustability like this, and then like this, right? And then of course it'll be height adjustable too on that arm. So I think if we can get this and this going, height adjustability on the arm, and the arm itself can slide in and out, we'll be able to position the tube wherever we want to at any orientation. And depending on how we design those, we might need to 3D print those based off of the chassis design, or we might need to see if we can make something that's permanently, or that's made for a permanent piece that can handle being used and abused, tubes putting themselves on the clamp, taking off, that can handle welding temperatures as well. Not direct welding, obviously, but it'll probably get up to several hundred degrees, and I want to make sure that it'll be able to handle that without getting weak or catching on fire. But it'll probably be metal, some kind of metal piece. So I wanted everybody to do research on that because I'm kind of stuck on this design. I like it, but obviously the more eyes and the more opinions, the better. We probably won't start on this until the spring, or we may start on it sooner. I don't know. Um, but I definitely want us to get a jig going by the time the car is finished testing in, or starts testing in early February. Because I don't know if you heard, but the plan is to have the car testable, fully testable, not just running, but like, you know, tires on the ground racing around in the parking lot testable by the end of January.
No, I didn't know that.
Okay. Yeah, I guess. Well, it's okay. I'll elaborate twice. So, Stephen wanted the initial rolling date. We used to call it a rollout date, but I guess it's just a rolling date. We want the car on the ground, drivable, maybe not raceable, but enough to drive it around, move it, make sure it's structurally sound enough to even begin testing. Nothing falls off, nothing comes loose, stuff like that. He wanted that to happen by November 1st, which I think is a fair goal because it already has a fair bit done to it. The engine already starts. Uh, we just need to finish the rear hubs and axles. But the car should be able to move by November 1st. And then we'll finish all of the support systems for it, the ergonomic systems, the braking, and have it ready to be raced or practice racing, usually on our own parking lot, by January 30th, February 1st, somewhere in there. Right. So that way we can have 4 months of testing during the school, or 3 months, 3.5, you know what I mean? So that's the goal. So basically around the time that it's getting testing, I want to start making this jig, actually producing it. Because I have no idea how long this is going to take. Shouldn't take us that long, but we definitely need to get working on this sometime in the next, or in the spring semester. So we're going to have one for the body, like these orange pieces, for the entire car as a whole. But then I also wanted to make some for the roll hoops. I don't know if you remember, but I did mention that these are all one-piece continuous hoop. They're not cut. They're not welded together. It's one bar that we have to bend. And it's hard to get that right. I think they were really slow and really careful this last time. They still had to do it about 4 or 5 times, I want to say.
Wow.
So I want to see if making a jig would help that. Possibly a jig with some bending capabilities built into it instead of just like measuring and placing it in there. But again, we all need to do more research on that. Are you going to go did Steven announce a safety training date yet?
No, not that I know of.
Okay. He probably needs to talk to somebody first about that. But when he does, I highly encourage you to go so you can get a look at the shop and the car. You won't be able to work on anything, but that's because it's not set up to work yet, either way. But you'll be able to see it. It's really cool. I actually took a video and a bunch of pictures, and I have them on here. And I'll show that to you later. And then I think I'll upload the video to YouTube so everybody can see. It's kind of a mess because the last time we actually worked on it was, before spring break. And I'm sure they were just cleaning up for like a few hours. And it's like, oh, we'll come back during spring break. And then it never happened. All right. So it looks kind of messy. It's a little rusty, but that's to be expected because it's not the surface finished or anything. But when we get back in there as a team, obviously I want us to get some hands-on with the metalworking, but we need to take an inventory of the welding supplies that we have, the spare metal that we have. We need to find a way to organize it too, because right now I think it's just laying on the ground or on the table. And we used to have a semi-organized rack for the metal because the bars we used to buy in like 20-foot long pieces or 10-foot pieces. So we used to have a rack for all of those to just be on, and we organize the tubing by wall thickness and size, and some of it was square. So we gotta work on that when we get in there. Do. Okay. So this was supposed to be the fun part. I was trying to make today fun. Nobody else is in here, right? It's just me and you, I think.
There's no one in the waiting room.
I don't think there's a waiting room. Let me get out of this and make sure there's not a waiting room, because that'd be really awkward. But no, I specifically set this one up to not be a waiting room, because I noticed you messaged me last time, which I did see it. But by that time I saw it, I was like, oh, it's been like a day, so I'm not going to message her. It's kind of... So this one, I think all going forward, I'm not going to have any waiting rooms, so everyone can just pop in. Because it's not really noticeable, at least not to me, when there's like a person waiting. So yeah, no one else is there. So I guess you'll be the first one. What did you actually want to do in the shop? I think you specifically said welding, but is there anything else you want to get your hands on? Like any type of experience you want with metal working?
See, I feel like I'm lacking the knowledge to, I guess, know what I want. But as of now, I guess, just want the experience. So
Okay.
yeah, I think it's just a little more research and see what I can actually get my hands on.
Okay, I'm writing this down so I remember, because I keep these PowerPoints. You can let me know if this sounds dumb. Does that sound fair?
I don't see anything.
Oh, that's right. I stopped recording or screen sharing. Okay. Does that sound okay right there?
Yeah.
Okay, that's fair. I want more time on the TIG welder, which is, I don't know if you ever seen anybody welding where they have like the welding torch and a long rod in the other hand. But that's what TIG welding is. You're basically melting an external rod of metal onto the joint, and then it solidifies and makes kind of a bond. Like glue, but in a really cool way. Whereas MIG welding with an M, the metal actually comes out of your torch, which at this point I just call it a gun, I guess, because it's got a little trigger on it. The metal comes out of that, there's an electric current that goes through the wire, and then when the wire arcs and grounds onto the metal chassis, it melts the metal wire coming out of the gun, and then that melted material becomes the glue. So basically MIG is like internal with the gun, and then TIG is external with the stick.
Oh, okay. See, yeah, I think I just need more research.
That's cool. I actually did used to have access to some welding books, and I think we might have some in the SAE archives, so we can look through those sometime. And I'll put those in the chat so everybody can grab them. I think I kind of went over this, but I'm just going to touch on it again. So again, it's used to set up all the work pieces or several pieces while we weld on them, or we can just play with the dimensions or the shape and see what else we want to get from the chassis. Kind of that real life experimentation going on instead of just messing around with SolidWorks or just conceptualizing it. We can see it. For the SAE chassis, we can position multiple major pieces in precise locations. That's the whole point of this, is to try to get some precision out of it, right? Because if I just get a bunch of like flexible like clamps, you know, it's not really precise. I want to have a way to measure its actual placement in there. So we'll have to factor in measurements to the adjustability as well. Maybe put like a ruler on every single sliding piece and just see how that goes. For the most part, we measured everything. We designed it in SolidWorks, which I think goes up to like 6 or 10 decimal places. We don't need that. But for the most part, when I was doing it, the suspension, the front suspension floating piece that kind of floats out in front, I measured it. I try to get it to within 1/16 or 1/32 of an inch on a tape measure, which was kind of the best analog measuring device we had. Does that make sense?
Yeah.
Sorry, is that overwhelming a little bit?
Uh, a little.
Okay. So this piece right here, let me go back a little bit. So we started with this piece coming off of the front roll hoop. This front part was just hanging in midair by itself.
Oh.
Um, because it's not directly in line with this piece, it's also not directly straight out from this. It's at an angle, and it's not directly parallel with the ground. It's actually upwards a bit. So in X, Y, and Z, it is actually off axis. So I had to find that point in 3D space and then hold it there while somebody welded this. And then this is just hanging out like a twig from a tree. And then we would measure it again because welding will actually impart a little bit of stress on this, and if there's nothing holding it in place, it will actually tend to lean one way or the other.
Mm.
So we would weld it, and let's say we would weld on this side, it would actually pull it in a bit. But then we need to weld the other side too eventually, so we kind of do this. But you can't put too many welds in it because then it becomes stuck in place, and you don't want that if you ended up pulling it off of it where it needs to be. So especially for pieces like this, I'd like to get something that we can use to more precisely locate this, because I did spend about 30, 40 minutes on one side and then 15 or 10 or 15 or 20 on the other, positioning it. They welded it a little bit. We readjusted it with a hammer, a gentle hammer, but with a hammer. So something like that. And then we put all these in afterwards, just as support. But these cuts, even though they're laser cut, they're not precise enough to locate it in 3D space. Does that make a little more sense to you?
Yeah.
Okay, let's see. What else did we do? So why do we want to jig? Why can't we just do it by hand? I mean, it only took like a week or two last time to do the whole entire process. So if it's so fast, why do we want to save time? Since we weren't really hurting for time, before. Uh, like I said, it may help speed up production on certain assemblies or pieces, right? A big thing is that with the chassis, we measure about 10 times on everything because we absolutely do not want to do it again. If we did have to do it again, uh, the business schedules may not line up with our schedule, and it throws everybody back that wanted to work on the car. Because when the chassis is done, that's the car now. So everybody wants to get hands on with it. And if we have to tell every single group, hey, sorry, we screwed up, you got to wait another month before we can get all the pieces and parts together and manpower to reconstruct it, that just throws everything off. So if something bad happens and we do need to reproduce it, we can set up the jig and then hopefully reproduce it in as little as a day or two if we get the metal laser cut. And then hopefully it won't be a big enough thing that we have to like destroy the first chassis. People can still work on it with the correct measurements that are in there, and then we'll just build a new one that is correct. Hopefully in like a day or two, as opposed to like 2 weeks. And lastly, of course, if we can move bars around without everybody, like 10 people holding hands in various places, getting their hands in the way, we can look at it and see how it looks, how the driver would fit, how an engine would fit, especially if we're redesigning engine, or sorry, if we're getting a bigger engine, a 2-cylinder, a 4-cylinder, or a different suspension, like independent rear suspension, everything rear of the major roll hoop would have to be redesigned, everything. So hopefully it would help us experiment with that. And I wanted everybody to do research on that. Like I said, I have one, but I'm mostly getting it from one website. I'm just getting one kind of view of what a jig would be. And it works, or it looks like it works. I mean, the guy obviously built the thing out of it, so it looks pretty cool. And there is a real life thing of this I'll show you in a bit. But there may be other ideas out there, other setups that we could benefit from or incorporate into our things. Is that something you might have time to just research in the next week or so?
I think so.
Okay. And it doesn't have to be official, like academic research. You have to like cite your works. You know, you have to use official published papers by all these doctorals. It's like, no, we just Google and see what happens. You know, some of the best ideas come from strange websites on the internet that you've never heard of before. It's like this guy's building one in his garage. It's so cool. Okay, so let's open up the rules. I think you had yours opened already, right?
Yes.
Okay, let me see. Where did mine go? There it is. Okay. I'm just curious. What are you viewing the PDF on? What program?
On Google Chrome.
Oh, okay. So you don't have like a list of bookmarks on the side for it, right?
No, there is bookmarks.
Oh, there is. It shows those.
Yeah. There's general regulations, administrative regulations, and all that other
I feel
stuff.
like I need to rework my Google and figure out why it doesn't show on mine. Okay, so go to F, chassis and structural. I have no idea why it's F. No idea.
Mm-hmm.
And we went through this stuff already. Oh, I hate that scrolling mode. There we go. Do you want me to re-explain some of this stuff?
Yes, please.
Okay. So the hoops kind of define the outer bounds of most of the vehicle, especially for the cockpit and the engine compartment. So the front roll hoop to the rear, you're kind of imagining there's a broomstick that goes right here, just because that's a long, flat piece that people will use to measure it. Primarily, you don't want the driver's head sticking above here because in the event of a rollover, this part may flatten out depending on your structure, and the only thing to protecting the driver is the orientation of this hoop, and the ground. So if his head sticks out above here, he's going to have a bad time in a rollover. Which
Okay.
it takes a lot for these cars to roll over, but they also are turning pretty hard. So if they hit a pothole or a groove, or if a tire blows out or an axle snaps, they're already in a high G turn and they can flip over pretty easily, I would think. So the driver needs to stay below here. The steering wheel does as well. The seat will have to, as well as seat belts. And then for the powertrain, any kind of gas filler neck they have, any electronics have to stay underneath this too. Same for this. This is more for the powertrain because obviously this is where the engine goes. But we do need to have the chassis built in a certain way that accommodates the rear suspension, the differential, and the engine. And none of those parts can stick above this imaginary line, right? And you have pretty much the same for this too. The roll hoop is shaped this way. Don't go outside of this boundary. Same for this, although this isn't usually a problem for people because they tend to have body work and or some kind of flooring for their vehicle. So you don't magically stick your foot outside of the car anyway. Does that make sense?
Mm-hmm.
Okay, so that's for the chassis components. There's also one with the tires, which it doesn't give us a lot of detail on that. It just says this is a volume described by the tires. That might be more for aerodynamic components, but we'll have to take a look at this later. It's not giving me a lot of information right here. This is something else. It's more of another redefinition. Component envelope, interesting. You will learn about this even more in your solids class. But basically, this is kind of a calculation that has to do with the area, the cross-sectional area of a tubing, versus that area's average placement to the center of the axis. So it's a relationship between, like, again, surface area and then how close it is to the metal. And then this is basically the stiffness of a metal, because everything in the universe, if you put force on it, it actually does elongate. Doesn't matter what the material is, it will elongate. This E modulus of elasticity determines how much it elongates, right? Which a higher E means it's stiffer. I know it's called modulus of elasticity, but more elasticity actually doesn't mean it's more rubbery. It just means it's stiffer. So then the naming gets kind of wacky. But like even this pencil is technically elongating as I'm pulling on it. Even the diamond will, but obviously by a very minuscule amount because of its stiffness. Whereas this, if I put force on it, it is bending because it has a much lower modulus of elasticity. Most of this is taken care of by just choosing our go-to metal of it's not stainless steel, it's not aluminum. What do you call it? It's a variant of carbon steel. I forget the exact number, but our options are in here. There are other options as well, but that's what we stick to because it's cheap and easy to manufacture and work with. I mean, if we had like a multi-million-dollar facility, we could use like carbon fiber everything all day, right? But yeah, we don't have that, and we're also trying to win cost, and we don't have experience with it. Again, we're going to triangulate points if we ever build a chassis. So not this, more like this. This is called a node, where it all meets.
Hmm.
And it just helps to distribute the force to other members, so you don't have too much force in one point, and it doesn't have a way to counteract that, and then this tube will bend, which obviously is bad. This is kind of a beast. Kyle has this. I need to take a further look on it. But there's a few documents for chassis that we have to list out like every beam that we have and kind of the orientation and the weight. And we will go over that when we get to it because it's very boring. Are you scrolling on yours or are you just watching me scroll?
I'm scrolling too, but
Oh,
mostly
okay.
just watching you.
Okay, that's fine. I just realized like, hey, I have it on screen. Duh. Like I didn't have to make you open it, but it's helpful that you know where it is too on your document. Again, different designated structures have different tubing sizes. Most of them are ABC. This one's a weird size, but we don't have a bent upper side impact member, so we don't have to worry about that. So again, remember that I component we're talking about, E times I?
Mm-hmm.
This is the I right here. Or this is heavily related to the I. Yeah, it's just different units and classifications. But they let you cheat. I mean, look, they just give it to you right here. Like, oh, hey, you just use 1-inch tubing at this approximate size and you'll satisfy this requirement. So it's nice that we have an already pre-existing industrial sizes for the tubing that we need. Makes it a whole lot easier to construct. Now there's standards for the metal. It needs to configure to the stiffness. And these are other things that have to do with that, but you're primarily looking at this right here. Welded properties for discontinuous materials such as joint calculations. I don't think we have any discontinuous joints, although I'll need to look up the definition of that. Alternative materials, yeah. So again, aluminum is lighter. You do tend to need more volume of it, but you can have a stiffer aluminum structure with less overall mass. It is more difficult to weld though. So people typically don't do it. It's also more expensive. Kind of the same thing with magnesium and titanium, but to a bigger extent, way more expensive. Obviously, a better material in terms of stiffness and weight, but working with it and buying it, very difficult. Steven wanted me to look into carbon fiber monocokes, but I'm like, I know. I want to get the chassis jig done before I look into building any kind of carbon fiber chassis at all, because it's not the same procedure. It's not like you're taking a bunch of tubes still. It's like you're building an actual 3D, a singular 3D object, like a beautifully sculpted piece of Play-Doh. It's one continuous piece, right? And then it has attachments for other points. So not like a steel tube chassis at all. If you see anything here that you're curious about, just let me know. If it seems really weird to you, it's probably weird to me as well.
Yeah, I just haven't taken the time to look at the rule book, but I'll do it this weekend.
Okay. And then I think the officers might be going to the shop again Saturday. I'm not sure if we're gonna make it like a weekly thing, but it seems like we've been going on Saturdays. So if there's anything you wanted me to take a picture of for you, or to find out, or just show you anything, just let me know. Did I ever show any of you guys pictures of how big the space is?
No.
I don't think I did. Okay, I'll have to look that up on my phone because I do have pictures of it. It'd be nice if I had a floor plan too.
So, what building were you guys in before?
We're in the same building still. We were in the PDSL, or Powertrain Dynamics and Systems Lab. Um, Basically, it's a building with two big rooms, front and back, separated by two doors. We had half of one side of the building, so a quarter of the overall space. It's actually a little bit less than that because there was a hallway running down the middle of it, or a hallway. Uh, it was a hallway because there's a bunch of cabinets kind of separating our space. So it was slightly less than half that space. It was probably about like 37% of one side. But now they moved, and it used to be a senior design building. So seniors would go in there to work on some of their materials on a mill or a lathe, just shape whatever metal they needed in welding, stuff like that, for their senior design projects. But because they built the new engineering building, they moved a lot of those goodies over and left us the building. Although there is one side of the other room that is going to, I think they said Steve Griffin, which is like a huge donor or contributor to the school. And he's basically using that to make his little office in an engine dyno, which I think is pretty
Mhm.
cool. So instead of us having like a third of one side, we're getting all of that side and then about like 70% of the big side, or the other side that looks like it was bigger. So we basically have like 80% of the building instead of like 20%.
Mhm.
And then all the other stuff, or most of the other stuff, went to the new engineering building. Have you been to the new engineering building?
I just walked around. There's a
Okay.
lot more study spaces and stuff and whiteboards, and yeah, it's really nice in there.
Yeah, there is. There was this one big room. I didn't get to stay in it long because we were trying to get somewhere. I think it's just a bunch of big tables with whiteboards, right?
Mhm. Yeah.
Yeah, I need to spend some time in there and just try it out and just see how it goes. But the machine room is attached to that room, or just through a door or a small hallway. And I think you can walk in there kind of whenever you want. I'm not 100% sure, just kind of peek. But that's where the manufacturing labs are going to be. I don't know if they started those yet because of Corona, but yeah. I don't know if they're actually going to do this for us. I've never heard of them actually doing this, as long as they can verify what material we have. This might be primarily for alternative materials. But if they're like, oh yeah, you use carbon steel, like, okay, yeah, you're fine, it passes. I need to ask Kyle about that because I don't think I've ever heard of them doing that test. Lap joint. That's for laminate samples. So that's for like carbon fiber reinforced polymers. We went over that already. Primary structure. Bent tubes. So this is kind of an important thing. Probably only for like really new teams. But you're only allowed to bend a tube so tight. And the radius of that bend is relative to the outer diameter of the tube. So since all of ours is 1-inch tubing, we cannot have a bend that is tighter or has a tighter radius than 3 inches, which we normally don't. I mean, the top of ours is kind of squarish or flat, so we don't have that problem. Let me see if I can get a picture of that. I do have pictures of the chassis that I need to upload for everybody. I said I'll probably just put it on YouTube sometime. Oh yeah. So see, ours was, the intention or the design was for it to be flat right here, but when you have two bends that close, it's hard to make it like perfectly flat in between them. But basically, if we would have made this into like a kind of a cone top or a really triangular top, we could not have had a tighter bend than 3 inches because the tubing is 1 inch outer diameter.
Oh, okay.
So, I mean, that makes sense. I mean, don't bend a big tube around a really tight bend. It's the same for electrical wiring. They have similar rules, although I think theirs is 6 times the diameter of the wire, but that's electrical. So this is not us. We only use bent tubes for the actual row hoops. This is saying other than the roll hoops, so we can just ignore all that. Holes in the tubing, we don't do that, so we skip that. Fasteners and primary body structures. So that basically means if you have major members, I think, that are held together by nuts and bolts instead of welding, that's where this comes into play. Although, yeah. Yes, with primary structure. So this doesn't include things like the flooring or the seats that ergonomics has to worry about.
There's a lot that goes into this.
Yeah, a lot of it's really just safety for the most part.
Yeah.
Safety, comfort, and ease of use. Which, I mean, that's what a chassis is, because everybody would like to have as paper thin chassis as possible to save weight, but of course it has to be able to take the forces of a driver's weight, braking, suspension, power, and then an impact if need be. So if safety didn't exist, cars could go a lot faster, but then you would die. So that's bad. Oh, so this is here we go. The helmet of a 95th percentile male, for obvious reasons, because males are bigger than females. So we need to have a tall dude in there because we're not worried about short people falling out of the car. That makes sense?
Mm-hmm.
Okay, so be a minimum of 50 millimeters from the straight line drawn from the top of the main hoop to the top of the front hoop. Do you remember that broomstick thing I was telling you about?
Yeah.
That's exactly what this is. And it's not vertical distance per se. The broomstick is going to be at an angle, so you need to measure that 50 millimeters at a tangent angle. Does that make sense?
Mm-hmm.
So that is fun. I tend to just call that like 2 inches, which actually gives you like an extra 1 millimeter ish. So I overestimate on them. It's like, oh, it's 2 inches, because we build everything in inches. We're SAE. I'm not saying they prefer inches, but we used 1 inch tubing, so it's easy to just make everything else in an inch format. So I just convert this to 2 inches. Gives us a small little extra margin of safety. Oh, and then if we have bracing on the rear. So let me put my picture thing up. I don't know if this is looking dumb on the stream. So this thing. So the driver, there's going to be a cushion on this technically. I think the cushion's about 2 inches thick, or an inch and a half. I'm not sure. But the actual position of the driver's helmet has to be 2 inches away tangentially from these lines as well. I believe is what it's saying. Yeah, if the bracing extends rearwards. And then ours doesn't go forward, so we're fine there. So yeah, there's that consideration to be taken too, which we've checked this all a long time ago. Obviously, the cushion is going to help push the driver's head forward away from this, so that helps a lot. Oh, here we go. Ta-da. Okay, so does that make... you already got it, I'm sure, but that helps to visualize it a little bit better, right?
Mm-hmm.
Yeah. Oh, goody. I actually forgot that. So it's not this bar particularly. It's from here to the bottom of this. So this bar actually comes in more than the helmet does, obviously, but it's this line. So that actually gives us even more distance, especially with the headrest. Okay, I think they made somebody called Percy. I tried to rename him Bobby. It didn't work. They didn't like it. but I made one of these in CAD, an actual assembly, so you could actually take his head, rotate it, his shoulders, and whatever.
Oh.
But it was a little difficult for me because I'm like, wait a second, I can't just. I mean, you can make assemblies that go inside of each other and occupy the same actual three-dimensional space, but it looks stupid and it's not realistic. So I made them actually three-dimensional, kind of like 2.5 dimensional, but I actually gave him like his backbone. Oh, sorry. So I actually made these circles and I made them 2 inches wide, 2 or 4 inches, I want to say, but probably two. Each shoulder joint area was an extra 2 inches on that. So like his cranial part, his shoulders, and his hips actually stuck out 2 inches past that. So they were at least 6 inches wide. And then because they all connect, one of them went on top of the other one. So at his joints here and here, he's actually 10 inches wide, which kind of helps to give him some three-dimensional shape. But it also helps to make it a little bit more realistic so that we can extend his feet forward and have them touch the pedals without touching the steering column, because he doesn't have one leg going forward, he has two, and I gave them a bit of a straight gap. You know, I didn't just have two legs like this, I actually had them out a bit
Mm-hmm.
so they could fit the steering column in there if they wanted to use them in an actual finished 3D representation. So it took me probably about 3 times longer than it should have because I wanted him to have three-dimensional spacing for his hips and legs. But he's a lot more useful now. So, and then there's a real version of this in the shop that I think needs either to be remade or just re-verified because one of these dimensions changed from the time they made him. I think he's probably about 4 or 5 years old, and I think one of these changed just by 10 or 20, but I think it changed. The front roll hoop must be made of blah 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 with proper triangulation, of course, of course. It must go from the floor to the steering wheel, basically. Oh yeah. So the steering wheel, just straight horizontally, cannot come above the front roll hoop, which is interesting because for the most part, the steering wheel is not angled straight like this, right? It's usually angled up a bit and then it's slanted,
Mm.
right? Because obviously the steering shaft or the steering column, I think it's steering column, is pointing downwards into the car. So the steering wheel tends to be at an angle. So that has to be below this laterally. There's no broomstick test for that, but they're just going to eyeball it and make sure it's not higher. The main hoop must extend from the lowest up and over. So basically it needs to be tall. It needs to go from the floor up to wherever. So this is where I want us to pay attention even more. Okay, 10 degrees from vertical. So what that is saying, this part, I think that's what it's saying is this part can't be more than 10 degrees forwards or backwards, which I believe ours is just straight up and down, so we have no problems there. Where was I? Oh, any bends that are above its attachment point to the major structure. We have no bends above it, it's just flat. What that is saying is this right here. So if we had any bends here, we'd have to triangulate even more, but we don't, so we're good. This bend obviously is a pretty long bend. You can see it kind of goes from here to here, but it's triangulated technically right in the middle. So we're good on that construction. Oh, this is interesting. So the main hoop that lies below the side impact member can lean forward at any angle, but it can't lean backwards more than 10 degrees, which again, ours is straight up and down, so we're fine there. Okay, 380 millimeters. Just kind of remember that. It's saying the main hoop needs to be so wide. This boy right here, I think. Right? Yeah. Sorry if this is a little boring, but it's these specifics that we gotta really look over. Oh, 160 millimeters. So basically this brace can't brace it down here. It's not bracing a lot if it's on the bottom of the bar. It needs to be towards the top. Like basically if you're trying to keep something tall and heavy from falling over, like, I don't know, a fridge, you're not going to grab it from the bottom. You're going to push on it from the
Yeah.
top, right? Another steering wheel thing. Oh, that's interesting. So you can have it up to 50 millimeters away from this node, but still no higher than this. I think most people just aim to make it kind of in line or slightly below the top of the hoop because it gives you more leg room down here. So they just aim to put it as high as they can. Securely integrated, transferring loads, of course, of course. External items. What are external items? I think that's just talking about like radiators and stuff, but I'm not sure exactly. I'll have to bring that up with the powertrain team. Oh, could load the primary structure. Well, I don't think a radiator is going to put much stress on the primary structure, right? A radiator is like 3 to 5 pounds. We don't have any of these. We don't have any of those. All of our stuff is welded. I don't think we have any bracing. Well, other types of bracing, so we're good there. Is there anything else that's catching your eye here? Or is it just all kind of like alien?
Yeah.
It's okay. Once you get more hands-on with it, and hopefully we can lead you guys through some of the design. I'm sorry I didn't get the SolidWorks licenses yet. That's kind of my fault, but I didn't plan to do much of that
And
stuff today.
um, I emailed the IT department and they said just to go to the computer lab of the business building and they can get me set up.
Oh, okay. That's good.
Yeah. So I'm probably gonna go tomorrow after lunch.
Okay, yeah, just let me know.
And then
Cause
I'll see how it goes.
okay, because I still need to review with Kyle on what the proper way to construct it is. Because he was really good with the like three-dimensional construction and like empty space. It's easy when you're building off of something, but when you're just putting it there in the middle of nowhere, he was pretty good with that. We're good there. Oh, I forgot my dog was in here. Oops. Do you still or sorry, when you get SolidWorks working, you can use that file I sent in the group chat. It's actually the chassis that we're using.
Okay.
And I don't think it's had any major redesigns or anything. It just had some stuff added in real life, like the headrest and then some uh, seat support at the bottom, maybe. But you can get a really good look at that. If an upper support member is further than 100 millimeters above the upper side impact member. Oh, I don't think we have that. Because this is the upper side impact member, so I think it was saying if there's another one going, but we don't have that. Oh, then it has to be triangulated. I'll just triangulated. Yep, ours are supported by bracing, forwards and backwards. Ooh, sorry. I'm sure you've heard the story about this, right?
I don't think so.
Okay, let's see if I can make my screen go a half C's. How do I make this perfectly smaller? Okay, is that picture still big enough for you?
Uh, can you zoom in a little? Yeah.
Okay. Yeah, we're talking about this area. So this thing right here, it can be at an angle, but we just made ours flat, I'm pretty sure. It's supposed to, most people just tend to make where this part meets the front roll hoop, they tend to triangulate their suspension with that. Ours did not because of the design. That's okay because that's still triangulated. This is still about within 2 inches. You know, it's fine. So this is where we could have broken rules, but we have a judge on our side that's like, oh yeah, that's fine. You know, it's good. I think the main point was not to be like a stickler about 2 inches, but it's more about proper triangulation and reinforcement.
Is that is that the thing that Kyle mentioned last time?
Yes, this puts
Okay.
so this thing was not supposed to be more than 2 inches away from a node. He
Oh,
said it's just barely outside 2 inches,
okay.
but I don't think there's any force that can. Oh, my dog left. There's no force that's gonna basically jam the bar into this and cause this to buckle. So we're good. Because let's say you had a force. Let's say this car got hit in the back, right?
Hmm.
And then blah blah blah, something happened. And you put like all of the force into this part. So you would think that all of that force is going to come through to here, right? Well, according to statics, no. It's also going to get pushed through here, into a node, through here, into another node. Sorry, there's a node too. And then it's also going to put tension on this bar here. So there's not going to be enough energy from a rear impact that's going to deform it right here. And I think that's what they were getting at.
Okay.
Which it'll be fun to just get back in there and take measurements of all this stuff again anyways. Mm-hmm. And yes, there has to be some triangulation in there is what this is saying. Which we have plenty of that right there. Shoulder harness mounting. We usually leave this to ergonomics because they deal with the actual driver seat and seatbelt stuff. But we should be all good here. So no less than 30 degrees. There's going to be a picture of this in a second, I'm sure. Main hoop bracing. Yes, we have bracing. So this is the carbon fiber monocoque stuff, which we might look into this after we build a jig, but probably not for like at least 8 months. So if you wanted to build a carbon fiber chassis, I'm sorry.
No.
Front bulkhead support must have an equivalent EI. We basically used approved square tubing. For the front, I think Kyle kept square tubing because it's easier to just build an impact attenuator, which is basically a foam cone that sticks onto the front of the car. It's easier if that tubing is just flat. You know, it's easier to work on. Mm-hmm. We'll have to measure this sometime. I'm thinking, are they saying it needs to be at least 320? Oh, that's just what they designate as a side impact zone. Okay. Rough rule of thumb, very rough. Every 100 millimeters you can think of as 4 inches.
Okay. So
So
we're
this is
doing
about
everything in like English units. We're not doing our measurements in SI.
yeah, they do the primary planning in English units, but some of the, well, yeah, I want to say suspension does it in English.
Mm, okay.
The SAE rules a lot for either. That's why they give usually. I mean, obviously, it seems like they prefer millimeters because it's a little bit more of a precise unit. But we've always done inches. Although I think people work in both.
Okay. No, I was just wondering.
Yeah, I think we just use inches because most people are more familiar with it as far as visualizing. Um,
Yeah.
in designing, you can do either, but we tend to just use inches just because it's easier for everyone to just be like, oh yeah, it's this big, and it's like, oh hey, that's 470 millimeters. Like, it's what?
Yeah, yeah, no, yeah. That makes sense.
Which obviously, if I was doing this by myself, I would probably just use SI units. But like I would conceptualize with English units, then I would convert to SI, and then like round to the nearest 5 or 10, and then just go off of that. Oh wait, it said all of F7 was monocoque, right? Why am I looking at that? Yeah, we can skip that. Yay. Front chassis protection. So the anti-intrusion plate, basically, there's going to be a big front plate in front of this. Which, if this square is bigger than a certain area, it needs cross reinforcement. That's why that's there. We'll probably make this a bit smaller next year, so we can get rid of this. But there's still going to be a front plate covering this, and that's what the impact attenuator is attached to. When I say impact attenuator, I mean cone foam. Does that make sense?
Hmm.
Okay. It's basically like the bumper of the car. If you hit something, it's like, oh, squish the foam first. Don't hurt me.
Okay.
1.5 millimeter thickness solid steel. Oh, sorry. Also, I think the primary reason we work in inches, at least for the chassis, is because, well, we live in America, in Texas, and most people here are used to English units when you're ordering or working with metalworking companies.
Oh, okay.
Yeah. So it's just easier that way. I mean, they can do it, but a lot of San Antonio metal shops have. How do I say this nicely? They have older people working there who aren't as kind to metric as the rest of us. That makes sense. They might be like stuck in their ways.
Yeah.
Okay, this we'll have to pay attention to when we get there, but I need to ask Kyle about this. I think he said the plate is welded to the front of the car, but it's not welded uh, entirely, or maybe. He's interrupted. I think he said we can leave some space where it's not welded, but obviously the space where it is welded needs to be, sorry, the path where it is welded needs to be greater than the path where it's unwelded. Does that make sense?
Yes.
Okay. So, or we could also bolt it. I need to ask him exactly what attachment method we're going to use for that. Must not fail in a frontal impact. Basically, the plate of steel that's protecting your feet from being crushed by whatever you crash into must not fail. Kind of self-explanatory, right?
Mm-hmm.
Sorry, this is how chassis always starts, is looking over the rules. And then the fun starts. But we don't want to just have fun in the wrong direction. It's got to meet certain dimensions, which we already have one picked up, I think. Or if not, we can order one. I think SAE or Formula SAE directly sells them to students or has like a direct vendor so that you can pretty much say that, oh, it meets all the requirements of whatever. Does that make sense?
Mm-hmm.
Attachment, continuous or interrupted if if interrupted. More welding than not welding. All weld lengths must be greater than 1 inch. That's basically what that's saying is 1 inch. Or we can bolt it too. I'll ask Kyle and then I'll ask Jonah, because the brakes are in the front also, how we want to attach it. Ooh, structural adhesive. So basically, the cone foam is going to be glued onto that plate.
It's gonna be glued.
Hmm. You can also attach it by like drilling holes through it and trying to attach it with nuts and bolts, the cone foam, but it tends to just like fall apart and it doesn't hold up over time. You want to try not to touch it more than once. When non-crushable objects are okay, basically make sure your car squishes, I guess. I'm pretty sure the carbon fiber bodywork is not going to hold up to a front impact. I don't think it's that strong. Uh, when it's unreinforced, because it's just a shape. There's no actual structure behind it. It's not like a car bumper where you have an actual steel beam or a frame behind it. It's just there, and it has foam on the inside, so it's not going to survive like a crash into a wall or anything.
Mm.
So we don't need to worry about it because it will be crushable. I feel bad because Duncan's like, "Oh, record this and send it to me," and I'm like, "Oh, okay, yeah, I'll send you all the exciting parts." So these requirements, I'm pretty sure, will be met if we just buy the cone foam from the proper vendor. Well, this is met by us for the most part. Obviously, you don't want a car that's heavier than, how much is that in pounds?
Uh, I don't know the conversions.
I think it's about 2.2 and then some change. I use like 2.2. So I double it and then I add a tenth. That's my weird math brain. So it's above 660. So like don't exceed 660 pounds basically, which is pretty heavy. I think most vehicles tend to weigh between 400 and 500 pounds.
405.
I think, not 100% sure, but I think. Have you ever seen another campus's SAE car?
No. I did see
Okay.
some images online, but no, I've never seen one in person.
Oh, okay. So when I joined last fall, about 3, 4 weeks in, they had a thing where UT Arlington was hosting like an SAE event. It wasn't an official event, or kind of was semi-official, but it wasn't like for a competition or anything, right? It's like, hey, bring your cars out and just race them around. Let's have fun and get some testing going and meet people, right? Kind of like a testing team, a fun day, right, for SAE people. And it was mostly for Texas, but we had some people from Oklahoma and Louisiana coming too. So that was cool. But Arlington basically has like $100,000 SAE cars.
Dang.
So some of their stuff is way up there. And because of their budget, also, they have approximately 20 of their older cars on display, and they do race them too
Oh, wow.
during that time. Because, I mean, you can't race older SAE cars in current years. You have to build a new one every year.
Mm-hmm.
So stuff like this allows people to come out and race some of their older vehicles or get some of that SAE feel before the next competition. So that was really cool. I went to that. I took pictures of most of their vehicles and a lot of others. So I'll try to get those in here too. If I were to send a bunch of pictures to the group, do you think it'd be better to put them like in a zip file for all of you guys, or
Uh,
or what?
yeah.
Okay, I'll try to do that. Oh, here. When not using the standard impact attenuator, standard. So again, order it from the place that sells it to you, or that SAE says to buy it from. That's fine. And then fuel system. Is fuel system in chassis? Oh, I guess so. Okay, sure. Why not? Oh, so the fuel system must be inside the primary structure. So that one picture we saw in the beginning with the red dotted lines,
Mm-hmm.
You know, basically don't be outside of like the area where all the metal bars are. You know, because if the car flips or rolls over, it's supposed to be protected from the ground. Because if it slides on the ground, it makes sparks, and if there's sparks in gasoline, then bad things happen. And if bad things happen, this rule book gets even longer. Must be shielded from collisions, which, yeah, there's like an engine in the way. So I think it's pretty well shielded. I think I'll have to bring this up with powertrain, which I don't know if that means we need a plate or if an engine counts as being shielded, you know. Accumulator container, EV only. Sweet. The design of the, wait, is that part of, yeah, so F10, F11, EV only. And we're done. Kind of.
I have a question. How long
Yes.
is the meeting gonna go to? Because I
Oh,
would
I'm sorry. I didn't realize it
go
was
to
past 7 already.
the cafeteria since I live on campus.
You can go now, or just give me like 2 minutes to finish up.
Yeah, yeah. No, no, no. I was just gonna say like I gotta go like at 7:30 because cafe closes at 8.
No, that's fine. I wanted to keep these usually about 1 hour long, anyways. Okay. So remember how I told you most of the rules were about safety?
Mm-hmm.
There are some that actually help you design the size or the comfort of the vehicle. So most SAE vehicles tend to be about the same size because of these next 2 or 3 templates. So this template needs to be able to fit in the car while it's completely lowered vertically into the car, all the way down and then all the way up, right? So this is basically where the driver goes. Here's his butt, here's his legs, here's his knees, right? And then this is the front row hoop. So this is like the minimum size of the car. And we usually don't go much bigger than this because it increases the weight by a lot, yada yada. So because of this rule, I would say that's why most SAE cars are around the same size generally,
Mm,
right?
okay.
This is just telling you how to basically drop it in there. Da-da-da. Steering wheel can be removed. This needs to go through the front row hoop. So this gets passed through here. You remove the steering wheel and it gets passed in and it goes here. They flip it around basically, kind of like, oh, it fits, it fits, it fits. That. So we actually do have a cardboard cutout, or sorry, a wood cutout of this that we use. And we design it too and put it in SolidWorks and just kind of pass it through and make sure it fits. And this is just telling you how it gets fit in there. The only important thing really is that the pedals have to be all the way forward or all the way squished against, sorry, all the way close to the driver, I guess, in layman's terms. But that's more of an ergonomics thing. But this is something we need to design around, and ergonomics designs around this too. And I think that's all I have for you because, yep, that's pretty much it. Firewall, that's more ergonomics. They put a giant metal plate in there. And harness, that's ergonomics. Ergonomics. Also ergonomics. Yeah, that's what this is. I don't think we designed this in SolidWorks. I think it just gets added after they figure out the seat placement. So yeah, sorry for keeping you late. I think that's all I have for today.
No, 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 no worries.